Hello everyone. So today we will talk about the general guidelines to tackle any design question. So whenever we will go to any design interview question, there could be like certain 4 or 5 things we have to take in our mind. So we know that we have hardly 40 to 45 minutes to design, to discuss about each and every component. So the very first step I have split it into 45 minutes. So first 5 minutes what I am here, that a user should ask the question to the your interviewer, and immediately you try to close all those doubts, and immediately you should get ready with your functional requirements and non-functional requirements. So now the thing is, how to decide that what are the functional requirement and what are the non-functional requirement for any question. So basically it depends what kind of question is being asked. For example, if the question is like design a e-commerce website, right? In that case, what will happen, we have to immediately come with some very basic requirements, like user should be able to search the products, user should be able to put certain products into the wish list, and a user should be get a good recommendations according to his or her requirements. So always go to some basic functional requirement. Don't list down each and everything, because we should keep in our mind that we have limited time. If we list down, there could be so many functional requirements, but at the later point of time, within given 45 or 40 hardly minutes, we might not be able to complete. So let's go here with the very simple basic functional requirements. For example, uh, if somebody is asking design a like a social website, maybe something like Instagram or Facebook, then you should come up with the some very simple 3 4 requirements, like user should be able to make a post, he should be able to chat, he should be able to like others post, and he should be able to follow others. And those 3 4 requirements should be actually the basic one. And then it comes like non-functional requirement. So these non-functional requirements are the requirement which supports the functional requirement. So basically what happens here, if you guys know cap theorem, so according to cap theorem, there could be 3 types of non-functional requirement, like whether it should be highly available, whether system should be highly consistent, or it should be like fault tolerant. So you guys can read about cap theorem. So basically it says we can maximum get 2 of them, not all of them together. So maybe somewhere, so for example, if you are designing some website, e-commerce website, then there could be certain parts of that system. For example, if you are asking, if the question is that design something like Amazon website, then you would have to go like it should be like highly scalable, because there would be millions of users. So you can immediately say that functional requirement, the non-functional requirements, like it should be highly available, and user should be like uh, able to search their things in a very responsive manner. Maybe the latency is also expected less. So these kind of non-functional requirements you can always mention. So and it depends that what so for example, if you are dealing with the designing of certain like social website, in that case availability would be a winner, because consistency, certain limit we can tolerate it. So it depends on what is the question, and then accordingly we have to come up with this. So don't waste too much time on these 2 points, because if you are listing down so many functional and non-functional requirements, then you have to implement them and look at your timing, right? So that is also important. So within 1 to 5 minutes you guys should be clear with these two, list down all the functional and the corresponding non-functional requirement. Then we would be going to the next part of it. So next 5 to 10 minutes we have to do the capacity estimation. So basically what is the capacity estimation is, Yeah, so capacity estimation is very important part of your designing questions, because at the time of capacity you will get to know that what is the user volume, what would be the overall size would be maybe in next 5 years, how much the database part would be required. So you have to actually give certain figures about the capacity also, like if for example there are millions of users and all users had certain like 3-4 MB data, then you can get an idea directly that let's say you have like 100 millions of users and you have like every user has 5 MB of data, then you can directly get some idea that what would be the capacity, and maybe if this is ever increasing the system, then you can easily get the idea about it. I have another video where you can use certain techniques, shortcuts to immediately get the capacity estimation. I have put that link in the description so you can check about that. Because see, capacity estimation will give us an information that what database we have to use, and how we would be choosing the backend system of it based upon capacity. So after making the capacity estimation, then you will be go to choosing of the database, or basically you can say the backend system of your system. So this here a lot of questions might come. So according to the requirement, according to the nature of the question that you are tackling with, it depends whether we are choosing a backend like SQL or we are choosing no SQL DB. But we always see that it's never like we are just going with the backend with SQL or no SQL only. So for example, let's take an example of some e-commerce website. So if I ask you what would be your backend system for e-commerce website, then definitely it wouldn't be like SQL or no SQL. It would be kind of a hybrid approach here. Why it would be hybrid approach? We need SQL for the ACID compliance related stuff, and if the user volume is very high, there could be a lot of information that would be unstructured that we have to store in the NoSQL DB like Cassandra or Cosmos DB or MongoDB, any sort of such kind of DB. And also if we are supporting the search functionality in our system, then we might know we might need like something like what you call that Elasticsearch kind of DB for the search stuff. So basically most of the time it goes in a hybrid approach of the DB. We just cannot go with SQL and no SQL as look at the practical designing questions. So why do we need hybrid approach of DB? So basically in any system we have certain things even if we are designing a e-commerce website, for the transaction part like availability of the items, their prices, their categories, there are 4-5 things which are the common property of every product has, like so for those kind of thing, and also our transaction related stuff, we have to always go to SQL type of database. It could be like MySQL or Oracle or anything. But in all these kind of big system, we also have something we have lot of products, right? And all those products might have different kind of properties. So that is totally unstructured data. So for that kind of data we would be required like NoSQL, something like Cassandra or MongoDB. So most of the time we are finding that we have to go in the our hybrid approach of the database. So here we can give some capacity estimation figures and choosing of our backend system. There could be like a lot of follow-up questions as well. So we have to well versed with those ambiguities to get cleared. So then third point, it comes like 10 to 40 minutes we have to do the basically overall designing, explaining each and every point of it. So this would be like your backbone of your overall designing system. Here we have to take care like 7 to 8 points in almost in all the designing questions. So we should always go initially with the overall flow of the high level flow of the your search or your search part, or your maybe overall flow of your system. We have to make like certain boxes which will display the flow of data from DB to server, from server to UI. Those kind of flow always adds the values, and then those high level boxes can be explored more into more granular way. Basically you can go, and accordingly you have to put your scalability or availability or fault tolerance. So how we would be using this scalability, availability and fault tolerant? Basically it would be changed according to the question. So let me draw some overall high level flow of the boxes, which will make the things more clear. Yeah, so you guys can make this kind of high level flow of the boxes. So on the leftmost side, these are the users, and user request, basically you can call these like client application, and this will come to load balancer. Now when you are saying load balancer, there could be a follow-up question, what is this load balancer is doing, how does it work? So you guys can always say that this load balancer is a kind of a consistent hashing. So what does it do is it actually keeps the track of your servers. There could be multiple servers because you might have a highly scalable system. For that you need a lot of servers. So what happens, load balancer checks the status of it. So if let's say a lot of servers, a lot of requests are coming, then load balancer would be equally distribute those request accordingly to the different servers, so that one particular server doesn't get affected with the huge number of requests. So what will here, so in load balancer part, the person can ask, your interviewer can ask a lot of follow-up questions, so we should be well versed with those follow-up questions. So how does load balancer internally works? You might say that we are using certain hashing algorithm. Then there could be a question that what is the difference between why you are choosing as traditional hashing, or why you are not choosing consistent hashing, how does it take care? So we should be well versed with those follow-up questions. Basically whatever tools or technologies, whatever boxes we are putting here, we should be get clear, because a follow-up question can come from any component whatever you are saying. Now for example then you have these servers would be getting the request, and DB, definitely we have the DB layer, and we should look if there is any possibility if we can put the cache layer here, so that we don't have to hit the DB always every time. So these things basically we come up initially, and then we have to go more granular for the details of each and every box. So once we have done the high level drawing of overall flow, we will go to each and every components in more granular way. Then we would be looking for the how we can add the scalability or availability or fault tolerance. So basically this point number C depends whatever you have written in your non-functional requirements. So for example if you are making certain design system like certain booking system, or where a lot of transaction happens, let's say something like banking system, in that case what happens, your availability is not that important, but your that consistency is very important. So we have to check accordingly that who is the winner here. So if it is like social website, then you can tolerate the consistency if you are posting something on your Facebook, and if it is not immediately getting reflected to somebody who is your friend sitting in US or in India, then it is not a big problem. After a while it will be eventually consistent and it would be reflected. So here availability would be winner, that your system should not go down. Doesn't matter if it is not showing everything very latest, eventually it will show. But if you are designing something like banking system or some transaction system or some booking, let's say ticket booking systems, there your availability is fine, but the winner would be the consistency. Because if you are depositing some money and if it is not reflecting everywhere in your account, then you will get panicked. So here consistency is very very important. You need the acid properties here. So to achieve this consistency and availability and scalability, we have to look accordingly whatever question is being asked to us. And similarly with the fault tolerance as well. So this would be your another important step. There could be like a lot of follow-up questions. So how do we achieve this scalability part? So scalability part is in the our this flow as well. We have drawn, like here you can see we have 3 servers. Also we can have cache layers. So why these 3 servers there? Because we want our system highly available. So if one server goes down, the load balancer will enroute your request to some other server. Because this is highly scalable, then we need to have different instances of the servers accordingly. So now it comes that then how we can achieve like availability thing, scalability and availability. So for availability stuff, we have to have the multiple copies of our data. So for that case we can go to something like storage part, like Cassandra kind of thing, where Cassandra is very good at for the to have the multiple copies of its database. So for such kind of things we can go to NoSQL kind of thing. But for when it comes to the consistency, if it is like banking system or some other system where consistency is very very huge, in that case we will go to SQL, because SQL provides us the atomicity in our transactions. So we can go to SQL in that case. And then comes fault tolerant. So fault tolerant means basically if some part of your system got down, maybe some server went down, then your system is still should able to work properly. So in that case what happens, if we have like if this server goes down, then some other server would be take care, doesn't matter if it has latest data or not. So this you have to fit it, that what you are actually designing, so which part you have to take care. Okay, then we have to come like avoid single points of failures. So whenever we are designing system, we should always look, are we depending on certain a single point of data sources. In that case we have to have like multiple copies of those data, so that if one of them goes down, then we can up some other point. So for example in DB database also we can go to some master slave paradigm. So what is the master slave paradigm here is like, if you have single, you can if so you can have like this. So let's say you have one instance of your master where you can do a lot of reads, but you should have like you will make slaves as well. So these slaves are nothing but these are good at for the read heavy systems. You can have multiple slaves like this. So yeah, so let me take one more slave here. Yeah, so here you can see there is one master instance and same copy of this is at here at slaves. So what will happen, reads can happen from these slaves, and your update can happen at master, which would be eventually get updated to your slaves. So what we are achieving using this, we are actually achieving the highly availability of data, and also our system would not be bombarded. So we can achieve the highly. The next is adding cache layers. So we know that system should be low latency as expected. So to achieve the low latency, basically we should immediately get certain response, and if we always going to hit the DB, then there could be a possibility it might not be that efficient. So we should try that where all places where we can put the cache layer. So in cache layer we can have like LRU, cache theme, or LFU. There are so many themes. So we can put that cache in between so that the things would be immediately getting response. So we should look at where the cache layers are possible. Then we have to look for adding retry mechanism on failures. So there could be a possibility that we are designing something like where we are actually sending certain messages to some system, something like notification system. In those cases we are not we are not waiting for our request to get fetched in synchronous way. So we might be using like asynchronous queues. So in those cases we have to look if something getting failed, are we adding the retry mechanism or not. So we should always look. It should not be like if something got failed once, then it shouldn't be get lost. There should be a retry mechanism. And also look that where can we put the asynchronous queues. So asynchronous queues is like if we don't want the things done in real time, then we can go for asynchronous queues. For example, if you are posting something or you are sending a lot of messages to certain system, then in such situations you might not wait the things to get done in real time. Then we can have the asynchronous queues which can be taken care at a later point of time. But if you are designing certain system, like if you are having certain transaction request for example, then a user cannot forget it. He or she will wait till the time everything gets done, be it failed or be it successful. User cannot leave until it happens successfully. If you are purchasing something, you will not leave until your purchasing thing is completely done. You have done the transaction to make sure the things are on the way. But if it is something like you are posting some thing into your social website, or if you are sending messages to certain thing, in that case we can go to asynchronous queues, because these are not supposed to done in real time. Then we have to always look whether is there any possibility how can gather the data for analytical purpose and reporting systems, because a user behaviors would be important to track for the later point of time to make the reporting system so that we can generate certain feed. So we can have like some analytical reporting system. For example, after certain times, older data can be put to certain OLAP system like Teradata or Hadoop like system, where some Spark streaming can be run over it and could generate certain information which would be helpful to make the further decisions, and also maybe in the recommendation system that also would be important. Also we have to always look, is there any room for batching the processes. So it means like we should not go to like every kind of request immediately to fetch it. We can make as much as possible, we can batch the request and then come, so that we can avoid lot of unnecessarily here put and get kind of stuff. Let's batch similar kind of process to save certain bandwidth. So these are like few things which we have, general stuff which we have to take care. So like we have just very little time to get done the thing, so we have to go to most basic stuff to get immediately done. Then we have like 40 to 45 minutes, like 5 minutes at the end to any follow-up questions, any some other questions based upon the tools and technology you have used. So these are the certain general stuff we have to take care basically. Thank you.